Welcome to lecture 3 of the topic sum of two independent random variables. So we'll continue with the more questions on sum of two independent random variables. If x is a random variable uniformly distributed between 0 and 3, z is a random variable independent of x uniformly distributed between 1 and -1, u is the sum of x plus x and z, u is x plus z. What is the probability density function of u? So here, as per the question, x is a random variable uniformly distributed between 0 and 3. So the probability density function of x will be fx of x is equal to 1 by b minus a, 1 by 3 minus 0, or 1 by 3 for all x values between 0 and 3. For x greater than or equal to 0, less than or equal to 3, 0 otherwise. For all the other x values, fx of x will be 0. It is said that z is a random variable independent of x uniformly distributed between 1 and -1. So z is a random variable independent of x uniformly distributed between 1 and -1, or -1 and 1. Least value first, then the greatest value, -1 and 1. So the probability density function of z will be fz of z is equal to 1 divided by b minus a, 1 divided by 1 minus of -1, 1 divided by 1 plus 1, or 1 divided by 2 for all x values between -1 and +1, for z values between -1 and +1. So for z greater than or equal to -1, less than or equal to 1, and 0 otherwise. So we have the probability density function of x and z. Now it is said u is the sum of these two independent random variables x and z. So the probability density function of u will be fu of u is equal to nothing but the convolution of fx of x and fz of z, which is given by integral from -infinity to +infinity fz of z into fx of u minus z dz. Or you can take it as fx of x into fz of u minus x dx. So there are two formulae for probability density function of the sum. You can take any one. So here we'll take fu of u as equal to integral from -infinity to +infinity fz of z into fx of u minus z dz. Here fz of z will be 1 by 2, but from minus for z values from -1 to +1. For all other z values, fz of z will be 0. So since the integral is from -infinity to +infinity, you can split this into sum of the integrals, so that fz of z will be half in that integral, where z is between -1 to +1. For all other z values, fz of z is 0, means all the other integrals will be 0. So remaining will be integral from -1 to +1. fz of z means it is a half into fx of u minus z dz, and that half can be kept outside the integral sign. So fu of u will be equal to half into integral from -1 to +1 fx of u minus z dz. Now you need to find what is this fx of u minus z, then you can complete the integration part. Fx of u minus z, if you see that fx of x will be 1 by 3 for all x values between 0 and 3. So this fx of u minus z will be equal to 1 by 3, but for all that u minus z values between 0 and 3. That is u minus must be greater than or equal to 0, less than or equal to 3. So fx of u minus z will be 1 by 3 for all u minus z values greater than or equal to 0, less than or equal to 3. That means u should be greater than or equal to z and it should be less than or equal to z plus 3, or z must be u minus z is greater than or equal to 0 means z must be less than or equal to u, and u minus z is less than or equal to 3 means z must be greater than or equal to u minus 3. So for all z values which are greater than or equal to u minus 3, less than or equal to u, so fx of u minus z will be 1 by 3 for all that z values between u minus 3 and u, or for all that u values between z and z plus 3. Now integration is with respect to z, and that integrand fx of u minus z can be taken as 1 by 3 if z lies between u minus 3 and u, and here u is the sum of x and z, and if you see the least value of the sum, highest value of the sum, then u will be in between -1 and 4. So u is between -1 and 4, and see that integral is with respect to z, and the interval for z is -1 to +1, which is of length 2. So we'll split this interval of u from -1 to 4 into subintervals of length 2. -1 plus 2 means it is +1. So one interval will take it as u between -1 and +1. Then from 1 to, if you take subinterval from 1 to +2, that is 3. 1 to 3. Then it is an interval of length 2, but 3 to 4 will not be an interval of length 2. So what you do is, one subinterval you take it from -1 to +2. -1 plus 2 means it is 1. -1 to +1. The second subinterval you take it to 1 to 2. Then the third interval you can start from 2 to an interval of length 2 means from 2 to 4. So we'll split this interval of u -1 to 4 as -1 to 1, 1 to 2 and 2 to 4. As the first case, if u lies between -1 and +1. Now in that fu of u, which is a half into -1 to +1, fx of u minus z dz. You have to substitute for fx of u minus z and complete the integration part. Fx of u minus z will be 1 by 3, but that z value should be in between u minus 3 and u. Now we have taken u as value between -1 and +1. When u is -1, u minus 3 will be -4. When u is +1, u minus 3 will be -2. So u lies between -1 and +1 means u minus 3 lies between -4 and -2. Z should be greater than or equal to that u minus 3, whose value lies between -4 and -2. Z should be greater than or equal to that. But here the integral z with respect to z starts from -1 to +1. So lower limit z cannot be outside that interval -1 to +1. So start z from -1 itself, which will be greater than this u minus 3. Upper limit z should be less than or equal to u, and u lies between -1 and +1, which comes in the interval of z. So you can take any of that u value which is in between -1 and +1. So upper limit will take it as u itself. So fu of u will be half into integral from -1 to u. Then that integrand fx of u minus z will be 1 by 3 dz. 1 by 2 into 1 by 3 is 1 by 6, and integral dz is z, difference at the upper limit u and lower limit -1. So 1 by 6 into, it is u minus of -1, u plus 1. Second case will take the interval from 1 to 2. U lies between 1 to 2. When u lies between 1 and 2, u minus 3 will be, when u is 1, u minus 3 is -2. When u is 2, u minus 3 will be -1. So when u lies between 1 and 2, u minus 3 lies between -2 and -1. So z should be greater than or equal to that. In that fu of u, integration with respect to z, and z lies between -1 and +1. So z cannot be outside that interval. So start the lower limit as -1 itself. Upper limit, u, z should be less than or equal to u, and u is greater than or equal to 1, less than or equal to 2. Z should be less than or equal to 1, z is less than or equal to u here, and this u value is between 1 and 2. Z cannot be greater than 1, so this u, upper limit, you take it as 1 itself. So integral fu of u will be half into integral from -1 to +1. Then that fx of u minus z will be 1 by 3 dz. 1 by 2 into 1 by 3 is 1 by 6. Integral dz is z, difference at the upper and lower limit 1 and -1. 1 by 6 into 1 minus of -1, 1 by 6 into 2, 1 by 3. Then the third case, suppose that u, which we had stopped at 2, if it is greater than or equal to 2, less than or equal to 4. Then fu of u will be half into integral fzx of u minus z is 1 by 3 dz. Now you need to write the lower and upper limit. When u is greater than or equal to 2, less than or equal to 4, u minus 3 will be, when u is 2, it is u minus 3 will be -1. When u is 4, u minus 3 will be 1. So when u lies between 2 and 4, u minus 3 lies between -1 and +1. So in this case, that lower limit you can take it as u minus 3 itself, which is between -1 and +1, lies in the interval of z. Then the upper limit, it is u, and that u lies between 2 and 4. But z lies between -1 and +1. So you take u as 1 itself, maximum of the upper limit. So half into integral 1 u minus 3 to 1, then fx of u minus z will be 1 by 3 dz. 1 by 2 into 1 by 3 is 1 by 6. Integral dz is z. Take the difference at the upper limit 1 and lower limit 3. So 1 by 6 into 1 minus of u minus 3, which will be 4 minus u divided by 6. Next, the probability density function of two independent random variables x and y are fx of x, a into e power minus ax into the unit step function u of x. Fy of y is equal to a cube by 2 into y square into e power minus ay into uy of y, where a is 3. W means the sum of that two random variables x and y. Find Fw of W. So find the probability density function of W. First of all, the probability density function of x. Fx of x is equal to a into e power minus ax into u of x. Here a is a 3. U of x means definition of unit step function u of x minus a, which will be equal to 0 for x less than a and equal to 1 for x greater than or equal to a. Here u of x means u of x minus 0, so which will be 0 for x less than 0 and 1 for x greater than or equal to 0. So this fx of x will be 3 into e power minus 3x into 1, means 3 into e power minus 3x for x greater than or equal to 0, 0 elsewhere. Similarly, fy of y, a cube into y square into e power minus ay divided by 2. Here into, it is into u of y. That term u of y is missing, so you have to include u of y. Unit step function u of y will be 1 for y less than 0, for y greater than or equal to 0, and it is 0 for y less than 0. U of y is 1 for y greater than or equal to 0, and it is 0 for y less than 0. So for y greater than or equal to 1, u of y is 1 means a cube into y square into e power minus ay for a y greater than or equal to 0, and 0 for other y values elsewhere. A cube means 3 cube, 27 by 2 into y square into e power minus 3y for y greater than or equal to 0, and 0 elsewhere. So you have the probability density function of fx of x and fy of y. W is the sum of these two independent random variables x and y. So probability density function fw of w is the convolution of the probability density function of x and y. So fw of w will be integral from minus infinity to plus infinity fy of y into fx of w minus y dy. Probability density function of w, it is integral from minus infinity to plus infinity fy of y into fx of w minus y dy. Now here fy of y means it is 27 by 2 y square into e power minus 3y for y greater than or equal to 0. So this integral, which is actually from minus infinity to plus infinity, now it will be from 0 to infinity. Y should be greater than or equal to 0. Then only this will be 27 by 2 into y square into e power minus 3y. Y should be greater than or equal to 0. Fx of w minus y. Fx of x is 3 into e power minus 3x for x greater than or equal to 0. So fx of w minus y means 3 into e power minus 3 into w minus y, then dy as it is, provided that w minus y is greater than or equal to 0. That means w is greater than or equal to y, or y is less than or equal to w. So now it is dy, so integration with respect to y, where y should be less than or equal to w and greater than or equal to 0. Since w value, the sum of that two random variable w value lies between 0 to infinity, well, straight away will not split it. Integral which is with respect to y will be, integration will be from 0 to that w itself, which is from 0 to infinity. In place of fy of y and fx of w minus y, you can substitute. 27 by 2 into y square into e power minus 3y into fx of w minus y, which is 3 into e power minus 3 into w minus y dy. 27 by 2 into 3 means 81 by 2. E power minus 3y and e power minus plus 3y cancels. Remaining is e power minus 3w into y square. So 81 by 2 into integral y square into 3 into e power plus 3y. That e power minus 3y and e power plus 3y cancels. So fw of the w will be 81 by 2 into integral 0 to w y square into e power minus 3w dy. 81 by 2 into e power minus 3w, integration is with respect to y, so w has nothing to do with that integration. Keep e power minus 3w outside the integral sign. Integral 0 to w y square dy, and integration of y square is y cube by 3. Difference at the upper limit w and 0. So 27 by 2, because 81 divided by 3 means 27. 27 by 2 e power minus 3y 3w into difference of y cube at w and 0 means w cube minus 0 or w cube. So final answer will be 27 by 2 e power minus 3w into w cube. The probability density function of Erlang random variable of order 2 is fx of x equal to lambda square into x into e power minus lambda x for x positive and 0 otherwise. The random variable y will be x1 plus x2, where x1 and x2 are independent trials of x. Find the probability density function. So x1 and x2 are independent trials, random variables of x. So the probability density function of x1 will be fx1 of x is equal to lambda square x e power minus lambda x for x positive, 0 otherwise. Similarly, probability density function fy of fx2 of x will be lambda square into, replace x by y minus x, fx2 of x. So it will be lambda square x into e power minus lambda x for x positive. So now probability density function of y, integral minus infinity to plus infinity convolution of fx of x and fy of y. Convolution of the probability density function of x1 and x2, integral minus infinity to plus infinity fx1 of x into fx2 of y minus x dx. In this fx1 of x is a lambda square x e power minus lambda x, but for x positive, here negative values comes, minus infinity to plus infinity. So ignore negative values, start from x is equal to 0. Integral 0 to infinity fx1 means lambda square x e power minus lambda x into fx2 of y minus x. And fx2 of y minus x will be lambda square into y minus x e power minus lambda into y minus x, provided that y minus x is positive. Y is less than x, x is less than y, or y is greater than x. Integration is with respect to x, and x is less than y, greater than y. x is less than y and x is greater than 0, it should be less than y. So probability density function of y is fy of y will be, by convolution theorem, fx1 of x means lambda square into x into e power minus lambda x. Then fx2 of y minus x will be lambda square into y minus x into e power minus lambda into y minus x dx. Substituting x as y minus x in the probability density function of x2. Lambda square into lambda square is a lambda power 4 kept outside the integral sign. E power x into y minus x, then e power minus lambda x and e power plus lambda x cancels. Remaining is e power minus lambda y dx. And x should be greater than 0 by the definition of PDF, and it should be less than y. So integral 0 to y. So integration of xy minus x square with respect to x from 0 to y. Lambda power 4 into e power minus lambda y. xy integration with respect to x means x square by 2 into y minus x cube by 3, differentiate the upper limit y, lower limit 0. Lambda power 4 into e power minus lambda y. Put x as y, integration was with respect to x. So these limits of integration are x values. Put x as y square into y is y cube by 2 minus y cube by 2 minus put x as 0, whole bracket is 0. Y cube by 2 minus y cube by 3, denominator 2 into 3, 6. Numerator 3y cube minus 2y cube, y cube. So that bracket is y cube by 6. We have the probability density function of the sum y.